want to do is talk a few minutes about this idea of a derivative. The derivative is one of two things involved in calculus. The other one is the integral. And I'm going to talk to you about the derivative from the physics perspective, which means I'm not going to get into all the technical aspects of how to determine it. I'm just going to kind of go through what it is and the mechanics. Basically, what you need to understand is that when you hear the word derivative, you're thinking about the slope. It's the slope of a graph, and that's what it is. Now, let me explain. If you're given a linear line, or the equation for a linear line is simply y is equal to mx plus b, where m is our slope. And so if you're given the equation for a linear line, we can figure out the slope simply by looking at the equation and setting it up in this format. So if we have the equation 6x plus 2y is equal to 6, we can take this expression and simply rewrite it. Y is equal to negative 3x plus 2. My slope is negative 3 for this linear line. Nice, simple. If you're given the equation, that's not a problem. If you're not given the equation of the line, if you're given the line itself, a graph of the line, then what we do is we pick out 2 points. It seems pretty obvious. Let's pick out this point, and let's pick out this point. This point is 0, 3. This point is 4, 0. And we know the slope is simply the rise over the run, however you want to figure it out. In this case, it's negative 3/4. Okay, that's fine. So we can figure out the slope from a linear line by picking 2 points on that line and figuring out the rise over the run. That's great. Linear lines or graphs of linear lines are nice. It's easy to get the slope. That's a little bit unusual. A lot of times we don't get a linear line. Let's say we have a function that looks like this. And we want to figure out its slope. Now, if we looked at this graph, the graph looks something like this. And in order to determine the slope, we don't determine the slope for the entire curve. We determine the slope at a particular point. For example, I want to calculate the point right around there, which looks like it's about x is 1.5. Now, to do this, we have two ways we can approach this. We can draw a tangent to this point, which would look something like that. Really poorly done. There, that's a little better. Actually, that's not that good, but you get the idea. And then once we draw our tangent, we pick a couple of points along our tangent and calculate the slope of the tangent line based on rise over run, slope of the tangent line. That would work. There's absolutely nothing there's nothing wrong with that. That's perfect. Problem is, it's really hard to draw the tangent line. How do you get that tangent line? And what one person draws a tangent line, somebody else might draw it a little bit differently. And so here's where we have to take what's called the derivative. And the derivative is simply the slope of the function. So the definition of the derivative is that what we're going to do is we're going to take the derivative of this function. Now, think about it in this terms. We picked these points when we figured the slope of our tangent line. we picked a couple of points on our tangent line. If I moved these points in a little bit closer, I'm going to get a slightly better value for our slope. I'm going to have a more precise number, but it's harder to pull them in closer because basically that means we're drawing a shorter tangent line. Ideally, we want to take the tangent line on a very, very small. We want to find the slope of the tangent on a very, very short tangent line. We're looking at the difference between these 2 points. What calculus does is when this difference, when the delta gets really small, when it approaches 0, that's what happens with calculus. Okay. To understand this idea, you might want to look at the integrals. Actually, integrals are a little bit more difficult than derivatives, but it helps to understand what happens when the change between 2 points gets very, very small. That's when the calculus kicks in. The definition of the derivative of a function is we're looking at the change in the function, the change in x raised to some power with respect to x. And how to calculate this out is simply you bring the power down, you decrease it by 1, and you apply that to every term in the expression that has an x in it. And I'm going to work through this process. This expression right here is identified on the AP Physics formula sheets. Like I said, I'm not getting into all the technical aspects of how this works or why this is. I'm just getting right to the nitty-gritty details. So, if I want to take the derivative of this function y with respect to x, another way to write that is dy dx. And basically what I'm going to do is I'm going to take the derivative with respect to x of negative x squared plus x plus 2. And then what we're going to end up doing is distributing. The mathematicians probably don't like that word, but I'm going to distribute that d dx throughout my parentheses. In other words, I'm going to take the derivative with respect to x of negative x squared plus the derivative with respect to x of x plus the derivative with respect to x of 2. And I'm going to follow, for each expression, I'm going to employ that idea. Let's break these up individually as I do this. And so when I take the derivative with respect to x of negative x squared, what's going to happen is this 2 is going to come down, and I'm going to have negative 2x, and then I'm also going to take 2 minus 1, which is simply 1. So my derivative with respect to x of negative x squared is negative 2x to the first, which is simply just negative 2x. This second term, remember, this is really written as x to the first. And so when I take the derivative, I'm going to bring this 1 down. And so I'm going to have 1x. And then I'm going to subtract 1 from my power, which is 1x to the 0. Well, x to the 0, anything to the 0th power is simply 1. And so this turns out to be just 1. The derivative of x with respect to x is 1. This last term, think about it, there's 2 things going on. 1, think about it in terms of, this can actually be written as 2 times x to the 0th power. If I take the derivative of that expression, I'm bringing the 0 down. I'm subtracting 1. This whole term, though, is 0 because I'm multiplying by a 0. That's what makes that go away. So when I take the derivative with respect to x of something and there is no x in that term, whether it's a constant, this could have even been 2z. And if I take the derivative with respect to x of 2z, I'm going to get 0 because there's no x in the term. Again, the mathematicians are probably dying over the way that I'm explaining this. That's okay. I'm kind of doing the shortcuts because they will get into the technical terms. So my original function, y is equal to negative x squared plus x plus 2. The derivative of this function then is negative 2x plus 1. And what this equation is, this is the equation for the slope of the curve, for the slope. So if I want to find the value of the slope for y, let's say I want to find the slope when x is equal to 2. I take the derivative of y with respect to x, negative 2x plus 1, and then I plug in 2 for x. So then what that's going to give me is negative 2 times 2 plus 1, negative 4 plus 1, which is negative 3. So at x is equal to 2, my slope has a value of negative 3. That's the short on the derivatives, on how to calculate the derivative and what it means. The more complicated the expression, the more complicated the derivative. But this is just an introduction to how to do these things. Hope that was worthwhile. Good luck.